about 9 years, okay? But I've been doing it for long enough to know that we cannot start the show without a very special ingredient. And who thinks that ingredient is air? Makes sense, right? It's in the title. But who thinks maybe it's liquid instead? Okay, let's get a little more advanced here. Who thinks maybe it's liquid air? Trick question. Yeah, the actual ingredient I need is you. And 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 you. It's everyone in my audience. And that sounds really nice. Like, yes, I need an audience for the show. It's very sweet. No, I need you because you are made of stuff. That's important, okay? You are stuff. Does that sound weird? Maybe a little bit, right? So I think we have to figure out what stuff is. So, first, do you see any stuff on the stage?
Yes.
Okay, did you see stuff in this museum?
Yes.
Do you have stuff at home?
Yes.
Okay, what is stuff? Ah, there we go, right? Because when we're talking about stuff, we're talking about things, objects, materials. I can just group a whole bunch of things together here, like this broken piece of balloon here, this metal thing, this sign that says science can be noisy. This is all stuff. A pile of stuff, right? Things, objects. If we want to get a more scientific word for this general term here, we use matter, okay? All this stuff is matter. All the stuff that makes up you, your skin, your hair, all that stuff is matter. I am matter. The air we breathe is matter. Matter is all the stuff around us, okay? Now, we can break that stuff, that matter, down into several different states to make it a little bit easier to classify, okay? Now, I'm pretty sure everybody here knows their states of matter, so we're not going to spend a lot of time on that. But first one we're looking at, on this sign, says what? Do you see any solid objects on the stage? Do you think this table's solid? Let's find out. Feels pretty solid. How about this wall? Do you think that wall's solid?
Yeah.
Ooh. Yep, okay, it feels pretty solid. How about my nose? Do you think that's solid? Ooh. I always like the split there. Some people say yes, some people say no. You're right, it may not be as rigid or tough as the table or the wall, but this is still a solid object, okay? Your skin, your hair, your clothing, even though it can fold and bend and change its shape a little bit, it still has a bit of a structure to it. If I were to take my nose off and drop it into this jar, it'd be kind of weird, but it wouldn't immediately melt to take the shape of that jar, okay? So this is still a solid object. It's a flexible solid. But we need to talk about something that will take the shape of that container. The next state of matter that moves even more than solids. Liquids. All right, so if I pour it on the ground and it makes a big puddle, if I can drink it, coffee, water, juice, soup broth, stuff like that, liquids, okay? How about one that moves even more than liquids? What's this last one? What do you think it is? That's it, gas, exactly. Gas, just like the gases that make up the air we breathe. Now, are these the only states of matter? Are there only 3, or do you think there are any more? Think there's more? Does anyone know what happens if you take a gas and you get it really energized? It turns into something else that makes up stars, the sun, lightning. Thunder! How convenient! What follows lightning? That was weird. I'm going to move my microphone a little bit. Okay. So does anyone know what we call this 4th state of matter? It starts with a P. Okay. What are you doing now? Are you okay? I'm going to put you in my back pocket now. Okay, we call this plasma, okay? It's the stuff that makes up lightning, sparks, the sun, that's all plasma. But you notice I don't have a sign for it. And that's because these 3 are ones that we deal with all the time. Drinking liquids, eating solid foods, breathing air, right? So if you deal with plasma every day, you have a really cool job, but it's not something that we get to do all the time. Now, I actually want to focus on gas because I want to talk about air. Are we all breathing right now? Good. Keep breathing. Please keep breathing. Okay? But you're breathing air. Now, I mentioned that air is made of a bunch of gases. So can anyone think of a very important gas in air that's keeping our bodies alive? Do you know what it is?
Oxygen.
Oxygen. You got it, right? So, let's all take a deep breath. Go for it. Don't let it out. Keep it in. Okay, now let it out. Okay, so that oxygen is helping keep your body alive. You breathe it in, right? But who thinks that our air is mostly oxygen? Makes sense, right? It's good for our bodies, it keeps them alive. But, but, who thinks maybe it's like half the air you breathe? Who thinks it's like less than half? There you go, a lot more hands on that, okay? So oxygen is very good for the human body, but oxygen is also very good for something else, all right? It also helps keep this thing alive. What do you see here? Fire, okay? So here we have fire. In fact, a bunch of little combustion reactions going on, okay? So fire needs three things to keep it burning. You need fuel, like this wick or the matchstick. You need heat, which I got from friction on the box. And you need oxygen, or an oxidizer, okay? So if we were in a room that was full of just oxygen gas and I lit a match, what do you think would happen? Yeah, I would explode into flames, right? We don't want too much oxygen. Oxygen's very good for the body, but you don't want a lot of it, okay? Good job, everyone. Everyone handled that really well. Nice surprise. Okay, so we only have about 21% of our air as oxygen. That's it. That's it. Which means there's plenty of room for more stuff. So have you heard of carbon dioxide? How about water vapor? Helium? Hydrogen? Hydrogen was in that balloon, by the way. Very flammable. And then finally, argon. These gases we can shove into about 1% of air. So 78% of air is something that we haven't even talked about yet. There's one gas that makes up most of the air you breathe. It's not oxygen. It's not carbon dioxide. Does anyone know what it's called? It starts with an N. What is it?
Nitrogen.
So we definitely have nitrogen in the air, okay? So nitrogen gas makes up most of the air you breathe. So when you took that deep breath, 78% of the air was nitrogen gas. But you mentioned liquid nitrogen, because let's talk about gas nitrogen. Are you breathing it right now?
Correct.
Yeah, you're breathing it right now, and it's not poisonous, but you need oxygen to stay alive. So we can't just empty the room of oxygen and just breathe nitrogen, right? We can't see it, and it's also not flammable, so it's kind of a boring gas. Which means this is the Liquid Air Show, so you're here to learn more about this liquid nitrogen stuff instead of just the gas form of it. So, we're going to look at a different state of this nitrogen gas that you're breathing. All right, so if you already know a little bit about liquid nitrogen, that's great. I'm going to call upon your past experiences with it. But if this is your first time, just sit back and get ready to learn more about this liquid nitrogen.
Learn.
Okay, right away, I can see a lot of mist, vapor, steam coming off of it here. Can you see it bubbling in there? It's bubbling like crazy all over the floor, too. When was the last time you saw a liquid bubble and steam like that? When was the last time? Ooh, all right. So if you've had soda, Sprite, seltzer water, sparkling water, something like that, you might have seen it fizzy, get all sparked and bubbly like that. Have you ever seen a liquid bubble like that at some other point? Halloween? Okay. Good time for that, right? Making some things look all foamy. What's that? Yeah, steamed pasta, right? Wait a minute. Hold on. And what were you going to say? Yeah. Okay, so you might have seen this before if you came to see the Liquid Air Show, which is totally fine. But if you don't have experiences with this, we've already talked about fizzy liquids, right? Boiling liquids, like boiling water, I think there's one thing that we can learn. If we did not know anything about liquid nitrogen, and we stared at this stuff, it might be hard to tell right away if it's hot or cold. Because if it looks like both sparkling water or soda and boiling water, we can't immediately assume it's hot or cold, okay? Because I don't know about you, but I don't drink boiling soda, but I can't cook pasta in cold water. So right away, we can't tell if this is hot or cold by staring at it. But what sense do humans have that can tell you temperature? What sense?
Touch.
What are you going to say? Should I put my finger in there?
No. No.
Will that tell me if it's hot or cold?
No.
Yeah, right? But no, I shouldn't
No.
do that, of course, right? Because you don't check boiling water by sticking your finger into it. That's not a safe way to do that. We've invented tools to help us check temperature. And what tool can help us with that? What tool? A thermometer, right? I need a thermometer. So if I take a thermometer and I put that thermometer into my liquid nitrogen, we will find out right away if this is really hot or really cold. This is, what? Is that a thermometer? Sorry, it gets really dark back there. Hold on.
What was it?
That's a worm.
All right, got it this time. So if we take our thermometer, no, okay, hold on. Sorry.
What was he looking for?
All right, so if I take my real thermometer here, okay, you know what? I was hoping you wouldn't notice, but I actually forgot my thermometer today. This is all I have. Now, while this may not be the best thermometer, I'm going to see if we can perform a science experiment with this. This balloon might help us learn if this stuff is hot or cold. So first, let's take a look at these balloons. Flimsy latex balloon full of air, the same air that we're breathing, okay? So mostly made of nitrogen, gas on the inside, some oxygen, stuff like that. Now, let's make some predictions. If I were to shove this into the liquid nitrogen, what do you think might happen to it? What do you think might happen?
Shrink.
Ooh, who thinks it's gonna pop?
Shrink.
Okay, cool. So I probably should have pointed this out earlier, but I have a sign here that says science can be noisy. If you think this might pop, get your hearing protectors ready. You can use these guys like this. If you brought your own, so it'll be fine. Be prepared. But who thinks something else might happen? What do you think might happen? Ooh, who thinks it's gonna shrink? Okay, how about the opposite? Who thinks it's gonna grow bigger? No one? Okay.
Larger.
One person. Okay, cool. There we go. So it could pop.
What?
It could shrink. It could grow.
Bigger.
Who thinks it's going to turn blue? Why not? Hey, why not? We're making some fun predictions here. Let's see. Okay, so let's
Angela.
give this
Die.
a test, and let's see what happens. Here we go. In 3, in 2, in 1.
What the heck is going on?
It did. There we go. So not only
So
did
what
it
What happened?
freeze. I mean, I guess
It
we could say it like. I guess we could say it popped too,
It popped.
if it deflated, right? Should we try that again?
It deflated. How about
Right.
that? That's
Because
correct.
if you want to do a proper science experiment here, you got to try this again and
The
again
air
and
was
see if you get the same
condensed.
results. So, yep, red one does the same thing, and the orange one also shrivels up.
It's a temperature difference.
Okay, so yes, every time we put a balloon to the liquid nitrogen, they shrivel up, they deflate, they shrink. Now that's not perhaps the most exciting thing, and doesn't really teach us much. I think it's more exciting once we remove it from the nitrogen and just leave it there on the floor. Because if we watch closely, we're going to see that change again. As these balloons leave the nitrogen, they reinflate, they regrow. And I've never seen a balloon pop, lose its air, and then reinflate. So do you think we actually took any air out of these balloons? No. We did not open these balloons at all. The air was always in there. So we had to do something to change the air on the inside. So now we have to get smaller. Talk about some little small pieces of matter, okay? So all the matter around us, whether it is you or me, whether it's my shoes, my nose, the air in those balloons, the liquid nitrogen, or the air around us. All of this stuff is made of these little tiny little particles. Little small things called what?
Atoms.
Can I show you a single one of these atoms?
No.
No. I can try. I can say that there's one right in the middle of my palm, but it's also next to millions and millions of other atoms. So, to show you what these atoms can do, we're going to have to build a model. Now, this is called a Hoberman sphere. You might have played with one before. It's a pretty neat toy. But I just want to talk about the green things here on the outside. Okay? We're going to pretend that these green things are the atoms in the air that we breathe. So, let's give them some energy. Now, as we give them energy, we're heating them up. And as we heat them up, they start to move faster and faster. And as they get hotter and they move faster, they spread further and further apart. So you heat up atoms, you're going to spread them apart. But we want to talk about what happens if they get cold too. And if they get colder, you think they're going to keep moving away from each other? No. Now they're going to start to slow down. And as they get colder, they get slower and they come closer and closer together. And if we heat them up, we spread them apart. And if we cool them down, we bring them closer. If we heat them up, we spread them apart. We cool them down, we bring them closer. Are we actually heating up this sphere though? No. So maybe I should do another experiment just to show you exactly what's going on. This one using some actual fire. So here we go. Yeah, don't worry. I am the safety trainer for the museum. So I also know best thing about being a safety trainer is that I can create a volunteer team of safety captains. So does anybody know how to use a fire extinguisher? Cool, you're my safety team, okay? If I'm on fire, I will run towards one of you for help. But don't worry, I've done this a few times before, so I think we're good. Now, the best thing about this experiment, you can't see how warm it is, but I can tell you that it's pretty warm. And I know you're all very jealous right now because it gets very cold in this building. Very cold. Okay, but you can't see air, right? So we can't see what's happening above this chimney here. So let's get something that will contain that air. This is a Mylar balloon. So those balloons that you get at your birthday party that look like they're made of tin foil, that is Mylar. This is currently empty, which means it's full of air. So if we get that air on the inside hot, now we're causing those atoms to spread further and further and further apart. So just like we saw with our sphere, when we heat up atoms, they spread. Oh, okay. So you'll notice that the balloon grew bigger as the atoms got hot on the inside, right? See, that's a cool thing called convection. That's a neat bit of weather science. Heat goes up, cool comes down. Now, since it's moved away from its source of heat, it's starting to get cold, which means where do you think it will go?
Down.
Eventually, yeah? I hope, unless it gets stuck in the ceiling. Oh, it's coming down? Okay, hold on. Here, I've got it. Hold on. I've got it. We got it. There we go. As it cools down, you can now witness that balloon starting to shrivel up, okay? So, you heat up those atoms, they spread apart. You cool them down, they start to come closer. You heat them up, you spread them apart. Cool them down, bring them closer. Now, let's bring this experiment back to our balloons here. We put them into the nitrogen, we watched as they shriveled up. We took them out of the nitrogen, they inflated again. So, do you think the nitrogen was getting them hot or cold in order to make them smaller?
Cold.
Cold, definitely. You got it. Our liquid nitrogen is cold. It's colder than the air around us. It's so cold it was able to condense the atoms in the air in those balloons to make them come closer. We took them out, they got warm, spread apart. So yes, our liquid nitrogen is indeed cold. So if you knew it was cold, wonderful. If you learned it was cold, great job. But I want to know if anybody actually thought that it was boiling.
It was boiling.
Great job. Yes. It may seem strange to say that this is a boiling liquid, because when we think of boiling, do we think hot or cold?
Each element has a different
Hot,
boiling
right?
point.
Okay.
But if you think cold too, that's great,
Why
because
couldn't it
boiling doesn't have to mean hotter than you or me. Boiling just means that a liquid is heating up, the atoms are spreading apart, and it's turning into a yes. Now, water has to get warmer than us for it to boil. But liquid nitrogen is so cold, the temperature at which it stops being a liquid and turns into a gas is way below anything that we've ever experienced. So, to give you a bit of a temperature lesson here, 32 degrees Fahrenheit, 0 degrees Canadian is where we start to see a lot of things. Celsius, sorry. You got me. 0 degrees Celsius, thank you, and 32 degrees Fahrenheit, right?
Canadian.
It's where we see things freezing. It's where we see snow falling. Not this year, but you know. Do you think liquid nitrogen can exist at this temperature? No. Because if you were outside on a snowy day, you'd be drinking the air around you, which is definitely not healthy. So we have to get even colder if we want that gas nitrogen to turn into a liquid. So we're going to go all the way down to this number right here. Negative 320 degrees Fahrenheit, negative 196 degrees Celsius. In Fahrenheit, that's about 400 degrees colder than your skin is right now. This room can get cold, but nowhere close to that cold. Negative 320 degrees Fahrenheit is the boiling temperature. That means if I cannot keep liquid nitrogen colder than this, it stops being liquid. Since there's nowhere on Earth that can stay that cold, our liquid nitrogen can't exist for very long. In fact, I poured it on the ground, and there's no puddle, there's no wet spot, because it went back into the air as a gas. And then it went to the audience. And then you got a souvenir.
Your lungs.
Do you want more? Okay, so here's the deal. Now, normally, I just spend the rest of the show pouring it on the ground, and then everyone breathes it in. But I don't know if that's as exciting.
That's not funny.
Can we see the gas?
Giggle up.
Do you want it in its liquid form instead?
Yes.
That was a trick question. I wanted to see if anybody here was dangerous enough to do it. No, you should not take it home as a liquid, right? Can't that be dangerous?
Proper containers.
Probably. But the door's closed, and no one's paying attention to my show besides you. So let's try to do it. Let's try to sneak it out of the building, okay?
Let's do it.
I will totally give you some liquid nitrogen because, once again, as I said, I'm the safety trainer for the museum, so I can teach you the safest way to do it. Now, right, of course, you will need one of these things. This is a liquid nitrogen dewar. It is a container specially designed for carrying liquid nitrogen. So if you don't have one of these, we're going to have a hard time taking this stuff with us. So we're going to have to find a backup liquid nitrogen dewar. And the next best thing that I have with me is this can of Pringles.
Yeah.
Not the best container for carrying liquid nitrogen, but we'll see if we can do the job. Now, we need to talk a little bit about safety here. Liquid nitrogen is extremely cold. If it gets under your skin, it can give you almost immediate frostbite. Notice how I said almost. If it does splash into my arm, as long as it quickly rolls off, I'll be okay. I don't want it to stay there. But that is not the most dangerous thing about liquid nitrogen, okay? Let's talk about what makes it super dangerous, okay? We're going to put our container right here. We're going to cap this Pringles can, and we're going to talk about safety, okay? Sorry. We're going to talk about safety. So if you don't want it on your skin, you're going to need some gloves and goggles to make sure they stay safe. But the most dangerous thing about liquid nitrogen is not the cold. It's this, okay? Pressure. Liquid nitrogen cannot stay liquid, which means it's turning back into a gas. As it heats up and turns into a gas, those atoms are spreading apart, creating pressure on the inside, boom, which then escapes, okay? So a Pringles can is not the best container for holding that liquid nitrogen. So maybe we need something stronger, like a solid titanium tube. Now, we're going to put this liquid nitrogen in the solid titanium tube, and we're going to cap that with a solid titanium cork, okay? It's not titanium, it's a real cork. But if you have experience taking corks out of containers, you'll know that these things get really, really stuck. So if I were to really hammer this cork in there as hard as I could, you see that we're still having a major problem with it here. Okay, hold on. There we go. So here's the thing about liquid nitrogen, right? As it heats up, it's returning to its gas form. Now, that means the atoms are spreading apart, but they are spreading apart about 700 times. Whatever I put into this tube will take up 700 times that space as a gas. That amount of pressure is extremely dangerous, okay? Oh, thank you so much. There is no safe way for me to contain liquid nitrogen. Let me show you just how much it will expand, okay? I think we need a container that is designed to grow with gas, like a balloon, okay? Now, if we were to, say, put this lid on our container, This balloon is a 9-inch balloon. It is designed to
It's
grow
gonna pop.
to about
It's
9
gonna
inches.
pop.
Now, 700 times its original size is quite more than 9 inches. So
It's gonna pop.
it could pop. Or maybe I didn't put enough nitrogen in there and we'll get lucky and it will just
It's
stay
gonna
really,
pop.
really gigantic.
It's gonna pop.
Oh, I'm a little nervous that it might, yeah. Okay, so just in case it does, do you mind if I bring it closer to you?
Might be.
No? No? Okay, I should bring it
Yes.
closer?
Yes.
No, okay, I should bring it over here. How about that?
Yes.
Right about, like, right here. This is a safe spot, right? I'm not sure if I have enough nitrogen. Now I'm a little worried that I didn't put enough in there. So, oh no. I can't put it down now because it's going to explode. So as you can see, about 700 times its original size is a little dangerous. There is no safe way to contain this stuff, which is why I actually cannot give it to you in its liquid form. Because even if you did contain it, that container would explode. And if you kept it in a container that grew, well, that would be kind of obvious. Yeah, I think we ran out. I think we're safe. Okay, I can put it down now, right over here, without damaging my hearing. Okay, go, go, go. And then run away. Okay.
It's gonna pop.
Okay, whew. All right, so, I know, now I'm like really scared. Stay. Stay.
It's not gonna stay.
I think we're good. Okay, so, I don't think I put enough nitrogen in there. I think we're...
Yo, it popped. It popped.
You took your time. It usually doesn't go that long. Oh, man. Okay, so there's no way I can give you nitrogen.
I didn't
Even if
know.
we put it in a container like the Doer, that is designed to let that gas out over time, you would lose it by the time you left the museum. So the only way I can give you that nitrogen is in its gas form, which we know is not super exciting, so let's make it more explosive. Now, we're going to go back to our weather science. We saw that balloon rise high into the sky. As I said, that was something called convection. Heat goes up, cool comes down. That's how we get water droplets from steam, like... Sorry about the microphone, guys. That's how we get our water droplets from steam rising up into the air, convection. Now, when steam and water vapor rises up into our atmosphere, it gets really cold, like that balloon did, and before it comes back down, it condenses into these big fluffy things that float up there in the sky. Clouds. So my plan is to we can do two different things here. We can take my hot water, okay? We can go out into the roof and then climb on each other's shoulders and try to get this up to our atmosphere to cool it down. Or I can use my really cold nitrogen to cool it down here on stage. Do the nitrogen. We'll do the roof. You want to do the roof? Let's go. Come on. No, okay. I'll save you guys some time because that will actually take a few hours to do. So we're going to do the nitrogen instead. It's a little bit quicker. So here's the plan. I'm going to throw all of my nitrogen onto that hot water. Not only will it condense the water vapor into a massive cloud here on stage, but it's going to send the nitrogen into the audience, giving you a souvenir to take home. So remember, once you see that cloud, take a deep breath. Are you ready? All right, in 3, in 2, in 1.
What's going on? What's
And
happening?
just like that,
What's happening?
that nitrogen is spreading
Explain
around
it
the
to
entire
me.
room.
Explain it, Jai. Okay.
Oh, hi. Okay, so that nitrogen is now spreading around the entire room. So if you want to take it home with you, oh, there's a giant cloud. Where did that come from? All right. So now we have our cloud. We have nitrogen in the room. If you want to bring it with you, take a deep breath. Go on, take a deep breath. And then hold it until you get home. Is that a safe idea? No. Please keep breathing, okay? But if you keep breathing, you will always have nitrogen going into your lungs. And that is the only way that I can safely give you nitrogen from the Liquid Air Show. Now, if anybody has any questions about the show, feel free to come on down. I'll hang out right over here on stage. You can say hi. Otherwise, thank you all so much for coming to the museum. Have a wonderful day, and I hope I see you guys around. Take care, everybody.